For our next two standards, standard 18 and 19, we're going to be graphing lines of equations. Standard 18, we're going to look at the slope-intercept form, which I think you have some familiarity with. So what is it? Besides just knowing that it's y equals mx plus b, which I think a lot of you could have told me. It's also just a way to describe two variables, the x and the y, that gives us the initial value or the starting value and rate of change. So the reason that we would use slope-intercept form is so we know where we're starting and how much it goes up by. So first let's just identify the parts of slope-intercept. Make sure we can get that down. The slope is always what is multiplied to the variable x, and the intercept is always what's added or subtracted onto that. So slope is 2 on this one, and -4 is the y-intercept. On the second one here, slope is 1 over 2, or half. The y-intercept is +10. On this third one, the slope is -1/7, or down 1, right 7. And this doesn't have a plus or minus anything. When that's the case, you could think about +0. That wouldn't change it. The way it goes just though is that if there's not an intercept added or subtracted there, then the intercept is 0. The fourth one down there is tricky for kids sometimes, but simplest form, you will see it this way. The thing you need to remember always is just that we can always put a 1 in front of an x. So x over 4, that would be the same as if this had said 1/4 x. So the slope is 1/4 on this one, and the y-intercept is -16. Okay, pause that, get it all down. Alright, let's do it. Here's your 2 steps to graphing from slope-intercept. Plot the intercept first, and then count the slope. What's the intercept on this one? It's -3. Let's get that down. If you're using lined paper, here's a great chance for you to use those lines. And what I do is I use the blue lines to get my spacing on my y-axis. And then I just get that as close as I can to match on the x. So the y-intercept was -3. Here's the y going up and down. 1, 2, 3 is the y-intercept. And then this slope of 3 right here, think of it as a fraction. 3 over 1 means we go up 3 and right 1 from this point that we plotted already. So 1, 2, 3 over 1 gets me the point. Let's do it again. 1, 2, 3 over to the right 1. Connect your points. Let's do another. The intercept on example 2 is 4. The slope, or the m, is -1/3. Remembering that there's a 1 in front of there. And use the lines on your paper to get the y-axis scaled evenly. The intercept is 4. Let's do that first. +4. 1, 2, 3, 4. And then on the slope, we can either go down 1 to the right 3, or negative 1/3 could be up 1 to the left 3. You'll get the same line eventually. Since I got some more space on my graph in the lower portion, I'm going to go down and then right in this case. So down 1, 1, 2, 3, down 1, 1, 2, 3. Connect your points. This was a negative slope because I had the negative right there. And this is a negative line because it goes down from left to right, so that matches up. Alright, third example. I think that's the last one. Yep. Okay, remember that the intercept is 0 on this one because it did not have one added in. If you need to write plus 0 there every time, go for it. The slope, or the m on this one, is a negative 1/2. We'll go down 1 and right 2. That could be down 1, right 2, or negative 1/2 can be up 1 to the left 2. One more reminder, when you're drawing your graphs, use the lines on your paper to get these even. The intercept was 0, that's right there at the origin. And then I could do either of these really, because since I'm in the middle. I usually like to pick the down 1, right 2 is usually the way I like to do it. Down 1, right 2. Down 1, right 2. If I run out of room, I can go the other way. I can go up 1 to the left 2. Up 1, left 2. Connect your points. Add a negative slope because I was negative 1/2, and I have a line that goes down from left to right. So just to recap again, slope, m is the slope. We found that between 2 points on a previous standard. We've thought of it as rate of change also. And then v is that y-intercept. We might also think about it as what happens when x is 0. We might think of it as starting point, or initial value, or first value. We'll practice that in class on the next time I see you.